Okay, so we got one more video I wanted to sneak in here. This is really more of a big concept in data management courses, but it's something that we're required to cover in the curriculum, and it's kind of fun. So what we're looking at here is how to just create an approximate um, equation from using the data and using graphing technology. It's pretty simple. What I recommend is you use the website that I've linked above in the note. Um, or if you want, if you have a TI-83 or TI-84, those are the Texas Instruments graphing calculators, you can use that. Um, so let's take a look at this question. Okay, so this question here, they give us a series of data and they ask us to determine both the coefficient of determination and the equation for a quadratic, cubic, and quartic regression. So that just means find the equations for this set of data. It's really not too difficult. So we're going to use this app right here. That's from the link that I provided. You really can just basically use the same one. We're just going to retype them. I'll show you what I mean in a second. But one of the first things we have to do is we have to enter our data points. So what I'm going to do here is I'm just going to pull up Word and then or my document, and I'm just going to type them. So this likes to use fancier brackets. So 1 comma 0.31, 2 comma 1.21. Yeah, that's right. 3 comma 2.53. 1 0.31, 2 1.21, 3 comma 2.53, 4 comma 3.72. And you can put these directly into the document or into the the application on Wolffram. I'm just doing it this way so that I can just have minimal documents open. And the last one there was 5. No, I got 5 comma. Oops, that should have been 5 comma 4.91. And then lastly, I have 6 comma 4. Put a dot 4 comma 8.9. It's always good to just check out that you did everything correctly here, because if you don't, then you're not going to have the right answers. So I just want to check those. 1 comma 0.31, 2 comma 1.21, 3 comma 2.53, 4 comma 3.72, 5 comma 4.91, and 6 comma 4.89. So I'm just going to select that and copy it, and now I'm going to throw it into my app. Again, you could have just put it directly in here. So we're going to start off with a quadratic fit. So all I'm going to do here is I'll actually just run their regression first. So I just hit equals on the quadratic fit side. Okay, so now I'm just going to block out theirs. You can delete it. This is where you can enter yours, and then click equals. Okay, so now we see the regression. They actually give us one. So now what I'm going to do here is I'm just going to copy that in. You can just write this down. So it gives us negative 0.090148286 x squared, certainly quadratic, plus 1.64543 minus 1.444. And then lastly, they give us an r squared value of 0.980059. So that's the quadratic fit. So to run the next one here, rather than re-entering all the data, all you got to do is you just got to type cubic fit. So I just change the word quadratic to cubic, hit enter, and it runs it for us. The beauty of technology. So it gives us a whole new regression here of, if I want to here, maybe I can just write quadratic. Cubic. So the values are negative 0.01 or 0.0718519 x cubed plus 0.663016 x squared. Ooh, I missed the x on that last one. minus 0.6332275 x, and then plus, let's move this over just a little, 0.3, and then it looks like it has 1, 2, 3, 4, 6 is 7, with an r squared value of 0.998272. So there's the cubic. So we have our two equations. So the general idea is that without knowing anything about the data, we're always going to take the one with the highest r squared. So at this point here, the better regression is cubic. This isn't a huge data set, so naturally it's going to make sense that the one that we're going to end up choosing is going to be the highest regression, because you should probably know enough about functions now to know at this point that we're going to be able to hit upon the most points the higher the degree we go. But that's not necessarily going to be the case as we get into larger data sets. Okay, so lastly, we're asked to run a quartic. So I just changed the word cubic to quartic. Click enter. Okay, and now I have this data set. So I'm just going to write in the equation here. Maybe I'll just try to move that over just a little so I can see it a bit better. Quartic is negative 0.01375 x to the 4 plus 0.120648 x cubed minus 0.254306 x squared plus 1.07272 x minus 0.623333 with an r squared value equal to 0.995593. Sorry that this video is boring you, because it has just been essentially watching me do a bunch of data entry. So it actually looks like our cubic function has the higher r squared, which I find a little bit surprising. I almost want to run that again to see if I did this correctly. So I would have thought it would have been the quartic cubic. So I'm going to rerun the cubic, make sure I wrote that down right, 0.995593. And the cubic, did I write down right? 0.998272. So that did turn out to be the case. It's interesting. Or did I write it down right with the quartic? No, I didn't. Okay, so that's how you can catch your errors sometimes. I wrote down the adjusted r squared. So 0.999119. There we go. Okay, so sorry if I confused you there for a second. So now we have our three equations with our coefficients of determinations, the r squared. Sometimes it's written with the lowercase r, sometimes it's written with a large case 1. So that was part A. Get out that underline. And then part B, which curve would we choose as the best fit, would be quartic, because quartic has the highest r squared value. Again, when you're dealing with small data sets, it's generally going to be the highest agreed polynomial that you're going to end up choosing. As the data sets get larger, that's not necessarily the case. So the main reason I wanted to sneak this here video in was for those of you who are going to encounter this on the assignment. I just wanted to show you how to do this. So it's pretty much that simple. If you have any questions about it, just let me know in the forum, and I will do whatever I can to help move you forward. All right, thanks.